OrcaSlicer has quietly become the default slicer for a large part of the 3D printing world, and it got there by doing two things nobody else bothered to do properly. A slicer is the program that turns a model into instructions for your printer. It decides every path the nozzle takes, and it matters far more to your print quality than the machine does. So this is a tour of the whole application, where it came from, how it is laid out, the settings that carry the weight, its calibration suite, the painting tools, and how to read the preview. Chapter 1, where it came from and why that matters. OrcaSlicer is a fork of Bambu Studio, which was itself a fork of PrusaSlicer, which grew out of an old open-source project called Slick 3R. That sounds like trivia, but it explains the software. Every one of those forks kept the good parts of the last one and added something, so Orca inherits a decade and a half of slicing work. It also means the layout will feel familiar if you have used PrusaSlicer or Bambu Studio, and that settings usually carry the same names across all three. What Orca added on top was a built-in calibrations suite and a much wider set of supported printers, and those two things are most of the reason people switched. Chapter 2, the layout. The window is split into 3 tabs across the top. Prepare is where you arrange models, Preview is where you inspect the sliced result, and Device talks to the printer over the network. Down the left of the Prepare tab is a toolbar of manipulation tools: Move, Scale, Rotate, Cut, and the painting tools we will come to later. Down the right are the 3 settings groups, and this is the part worth understanding properly, because almost every question about Orca is really about which group a setting lives in. Printer settings describe the machine itself, bed size, nozzle diameter, and the start and end G-code. You set these once and mostly forget them. Filament settings describe the plastic, temperatures, cooling, flow. Process settings describe how to print this particular object, and that is where you will spend nearly all your time. Chapter 3, Process settings and which ones carry the weight. Process settings are grouped into quality, strength, speed, support, and others, and there are several hundred of them. You will meaningfully use about a dozen. Under quality, layer height is the headline. It sets the vertical resolution, and it trades directly against print time, roughly doubling the time when you halve the height. Also under quality is the seam position, which decides where each layer starts and therefore where the visible scar up the side of your print lands. Under strength, wall loops is the setting that matters most for functional parts. Strength lives in the shell, and 3 or 4 walls beats any amount of extra infill. Infill density sits next to it and is the setting people overuse. 15 to 20% is right for almost everything, and past 40 you are adding weight and time for nothing. Under speed, the one to understand is outer wall speed. It is the surface everybody sees, so slowing just that line while leaving everything else fast is nearly free quality. And in others, you will find the brim and raft settings, which is where to go when a part will not stay stuck to the plate. Chapter 4, the calibration suite, which is the reason to use it. Under the calibration menu, Orca ships a set of test prints that other slicers make you download from the internet as random model files. The temperature tower prints one object at a series of nozzle temperatures, so you can look at the result and pick the temperature that gave you the best layers and the least stringing. Flow rate calibration prints a series of patches with slightly different extrusion multipliers, and you choose the one that came out smooth rather than ridged or gappy. Pressure advance is the one people skip and should not. It compensates for the lag between telling the extruder to push and plastic actually arriving, which is what causes bulging corners. There is also a retraction test for stringing and a tolerance test for parts that have to fit together, and both answer questions you would otherwise guess at. The point of all of them is the same. They replace opinion with a measurement, and each one takes 20 minutes once rather than being re-argued every print. Chapter 5, the painting tools. The left toolbar has 3 brushes, and each one lets you overrule the slicer on a specific decision by painting directly onto the model in the 3D view. Support painting lets you force supports where the slicer missed something or block them somewhere you know you can bridge. We cover that properly in its own video. Seam painting lets you place that vertical scar exactly where you want it, usually tucked into a sharp corner or round the back, instead of letting the slicer guess. Color painting is for multi-material machines, and it assigns regions of the model to different filaments without you having to split the model up first. Alongside those, right-clicking any object gives you per object settings, so one part on a plate can print with different walls or supports from everything else. Chapter 6. Reading the preview. Most people slice, glance at the time estimate, and print. The preview tab is a genuine diagnostic tool, and it is worth 2 minutes before you commit an 8-hour job. The drop-down at the top right recolors the toolpaths by what you want to inspect: line type, speed, flow, or layer time. Line type is the one to start with. It shows you exactly where the walls, the infill, the bridges, and the supports are, so you can see whether the slicer understood the shape the way you intended. And the vertical slider steps through layers one at a time. Scrubbing to the layer where a previous print failed usually shows you the cause immediately. So, printer settings describe the machine, filament settings the plastic, process settings the job. Learn a dozen of those, run the calibrations once, and paint over the slicer where you know better. The thing that makes Orca worth switching to is not any single setting. It is that it turns tuning from a folder of downloaded test models into a menu item. And once your profiles are calibrated for the filament you actually use, the slicer stops being something you fight and becomes something you barely think about. If this helped, subscribe to Layer Logic. There are short videos on most of these settings if you want to go deeper on any one of them.